Hey guys, we are still in Unit 8, Lesson 1. We're just going to finish up the last little bit of these notes. So, what this is solving equations that have radicals in them or have rational exponents, which we know how to turn into a radical. So, let's go through our steps and then there's a new vocabulary term. Okay. First thing that we're going to want to do is isolate the radical. So in this first one, we're going to add 9 so that the radical is by itself on the left. Then to get rid of that radical, it is a fourth root. So we will raise it to the fourth power. Remember, exponents and radicals are inverses of each other. And then we're going to solve the remaining equation. Our last step, however, has to be to check for an extraneous solution. An extraneous solution is probably not something that you've ever heard of before. So over here in these additional notes, I just want you to write down what it is. It is when we solve an equation and we do all of our algebra correctly, we follow all the rules, but then the answer that we get, if we plug it back into the original equation, it doesn't actually satisfy the equation. And we're definitely going to look at 2 of those, okay? So extraneous solutions is what we need to check for. All right, so I'm going to zoom in now. And we are going to start with this very first example, okay? So, like I said, we will begin by adding this 9 so that we can isolate the radical. Negative 11 plus 9 is negative 2. And then we've got our fourth root of all this, 8k plus 12. All right, in order to get rid of that fourth root, I need to raise both sides to the fourth power. And so I usually say our square and our square root cancel, but same thing, okay? Our fourth power cancels out our fourth root. Okay, negative 2 to the fourth power is going to be, 16. And then on this left side, I have 8k plus 12. All right, let's subtract our 12 from both sides. And then divide both sides by 8, and I get 1/2. Okay, so the k equals 1/2, which seems perfectly legit. We followed all the rules, but we have to check our work. So let's do that over here. So we're going to check it. Okay. I'm just going to plug in 1/2. So the fourth root of 8 times 1/2 plus 12 minus 9 on the outside of the root equals negative 11. Okay. So 8 times 1/2 is 4. 4 plus 12 is 16. So I have the fourth root of 16 minus 9 equals negative 11. The fourth root of 16 is 2. So I have 2 minus 9 equals negative 11. And then 2 minus 9, does that actually equal negative 11? Okay, no, that equals negative 7, not negative 11. So this means that I got a solution, but it's an extraneous solution. It doesn't actually satisfy this equation when I plug it back in. So in this case, I have no solution. Okay, I have one extraneous solution, but I have no valid solutions. Okay, so that's kind of what it looks like. I will also include, I found this Khan Academy video that really does a great job explaining how these extraneous solutions appear and happen. So it's a short, like 6-minute video, and I'll just leave that for you to watch for those of you who are curious. Okay. All right, number 13. So the first thing that I want to do is subtract the 11. Okay, and then I can write this as a radical. Okay, or I'll show you how to deal with it as the exponent that it is. Okay, so I'm gonna kind of come over to the left to do my work. So I have 7p minus 1 to the 1/3 power. That's the same thing as the cube root, by the way. Okay, it would be a cube root equals 7 minus 11 is -4. So in order to get rid of this when you see it as a fraction, here's what we can do. We can multiply this or raise it to the 3rd power, because the 3rd power is the opposite of a cube root. So another way to think about this is that if you look at your exponents when you multiply them, 3 times 1/3 equals 1. So I'm left with nothing but the 7p minus 1. 7p minus 1 equals, and then -4 cubed is -64. Okay, let's add 1 to both sides. So I get a -63 and divide by 7. And I get p equals -9. Okay, so that's a potential answer. Let's check it and make sure that it's not extraneous, okay, or extraneous. So plug it back into the original. 7 times -9 minus 1 to the 3rd power plus 11 equals 7. Whoops, my paper got dragged. Okay, so if I multiply and put all of this together in here, I get -64. And that's to the 1/3 plus 11 equals -7. Okay, now the cube root of -64 is -4 plus 11 equals, is it supposed to equal -7? Why do I keep saying negative? It's not negative. -4 plus 11 is 7. So this one checks out. Okay. So that means that p equals -9 is a solution. It is a solution. Okay. Example 14. So let's look at it when it's like this, and we see more than one radical. Okay. So the first thing I'm going to do is, well, I have radicals on both sides. So I need to start out by just getting rid of them right out of the bat. Okay, so multiply both sides, or cube rather, both sides. Okay, so when I cube that, here's what I end up with. 14 minus 10n equals, I've got -2 cubed, that's going to be -8. And then that n comes out of the radical. So I just did that one thing and made this equation into a 2-step, very simple equation. Okay, let me add 10n to both sides and divide by 2. and I get n equals 7. So I just need to check it, okay? So let's see, I've got 14 minus 10 times 7, and it's a cube root, equals negative 2, the cube root of 7. So I'm plugging 7 in everywhere there was an n in the original equation. Okay, so let's see, 14 minus 70 gives me negative 56. And the cube root of negative 56 is going to give me, 8 times 7. And I need 3 of them. The 8 can break down to 2 times 2 times 2. So I'm going to have negative 2 cube roots of 7, which is what this other side equals. Okay, if you want to see me break down the 56 a little better, okay, I just did negative 8 times 7, and then this is the same as negative 2 3 times. Oops. And so that's a cube. There's 3 2's, so they could come out. So n equals 7 is definitely an answer. Okay. Here, you help me. We have one more problem, okay? All right. So, again, I see roots on both sides. So the first thing that I'm going to need to do here is to raise everything up because this is a square root. So I'm going to square both sides. All right. Okay, now this is, let me just show some of this work out to the side. Okay. So I've got 2 of those, so it's going to be squared. This is going to come out real simple. It's just going to be x plus 9. Okay. And so now out to the side, let me scooch my paper over. I am going to just do, okay, the square root of x minus 1 times the square root of x minus 1.
Oh, I'll put these back in the pot.
Okay. So the square root of x times the square root of x is just going to give me x. The square root of x times negative 1 is negative square root of x. Negative 1 times the square root of x.
I have one because I did try.
And negative 1 times negative 1 is positive 1. And so now I'm going to combine these. It gives me negative 2 square roots of x. Okay, so here's what I end up with. So let's go ahead and put this over here. X minus 2 square roots of x plus 1. Okay, so I still do have a square root here. So what I'm going to need to do is move everything over to this other side, okay, and try to get rid of it all. So let's do, if I subtract x and I subtract 1 from both sides, here's what I get. 9 minus 1 is 8 equals, these cancel, negative 2 square roots of x. Okay. And so now what I can do is just go ahead and divide both sides by the negative 2. So it's going to give me negative 4. Okay. And then 16. I'm going to square both sides to get rid of that square root again. So I get 16 equals x. And now what I need to do is I need to check it. Okay. So 16 minus or plus, 16 plus 9 is 25. Okay, and then the square root of 16 is 4, and 4 minus 1 is 3. So I get 5 equals 3, which is not true. So this is an extraneous solution. Okay, so I got 2 examples today of the extraneous solutions where when I plugged it back into the original, it did not actually satisfy an equal. Okay. All right. So that is everything that we need to know about solving radical equations. Okay. There is a practice assignment posted, guys. Until next time.